she is. Anybody have questions before I just jump right into what we're going to do? All right.
Actually, can I ask a question? It's
yes.
From 3.3, question 5.
3.3. All right, let me see. 3.3, number 5.
Yes.
Okay, let me see. Let me put this up here.
Okay, thank you.
Shaboo! There it is. Oh, let me do this too. This is gonna, hold on. Everybody just hold on. Hold on to your butts. Here we go. Let's see if this works. All right. So number 5 right here, right? Are you asking that because it's not one that I assigned?
You didn't assign that one?
I can't remember now. I thought I assigned 6.
I thought it was every single question, no?
Maybe. Hold on.
I think it was every third one.
Yeah, so let me, I don't know what, look here. Just everyone, please understand that this does happen sometimes. Here is all the assignments for the whole semester. Here they are. So in 3.3, it's 3 through 45, every third one. E3O means every third one. So 3, 6, 9, 12. But that's fine. I can do number 5. I like that because it's not something I assigned. So that's really awesome. It'll help you out with number 6. Are you with me? That's nice. So I just made your day, right? You got a lot less work to do than you thought.
Yeah, true.
Yeah, but let's do number 5 because people are having trouble with these. These are kind of, so I call these brute force problems because, and I don't want you to make you feel bad. I'm not trying to make you feel bad. There's very little thinking involved. It is a process. So if I want to know the average rate of change of f of x from A to B, then I would just do f of B minus f of A over B minus A. That's because average rate of change is slope, and slope is this, right? Y2 minus Y1 over X2 minus X1. The inputs on the bottom and the difference in the outputs on the top. Is everybody with me? I really want that to make sense. So you would do, for number 5, you would do f of B minus f of 1 divided by B minus 1. All right, so I need to know what f of B is. Okay, so down here I can do, what's f of B going to be? Well, f of B would just be 4b squared minus 7. Is everybody with me? Every single average rate of change problem, you do it like this. What's going to change? The function and the inputs will change. Well, big deal, right? So each problem, you just do exactly what we're doing. So now I know what f of b is. So f of b is 4b squared minus 7 minus f of 1. Well, I can do that down here. F of 1 would be 4 times 1 squared minus 7. That's negative 3. Cool. I like how I keep doing that, like. You guys are going to arrest me. Math boy, stop. Ah! So that's negative 3. So I can put that in here. Over b minus 1. Become a 1. There we go. So now watch what really nice thing happens. I get 4b squared minus negative 7 plus 3 is 4, negative 4. And then I can factor this. Now I did that in my head, but you got to show some work anyway. So then you get that. So something very similar should happen to your average rate of change problems here, right? You guys get that? Every single one of these problems will work like this.
Wait, why did you put -1 instead of -3 at the bottom.
Oh shit, I hit the wrong button. Dang it. I'm sorry. All right, sorry. So let me do this again real quick. So it was f of b is 4b squared minus 7 minus f of 1 was -3 over this minus this.
Oh yeah, true. Yeah.
Yes, okay. So on the bottom should just be the difference in the inputs, and the top is the difference in the outputs. I like it. Hey, Mikey. All right. So yeah, quite a few people had some trouble with these. If you get one of these, you understand all of them. And I think some of you guys just have to get used. So like, for example, number 10 gets more disgusting, right? Let's look at number 10. That's an example of a slightly more disgusting problem. My claim is it isn't disgusting. So how would I do this? I would have to do g of x plus h minus g of the other input, x, divided by one input minus the other one. Okay, that's nice. The bottom becomes nice. I have to figure out what the hell g of x plus h is. So I can do that on the side here. Is everybody with me? Do you guys see what I'm doing? So this is what I keep saying. This is a construction approach. The thing I'm trying to do requires me to know this. Do I know this? No. Okay, let me take a second. On the side, I'll figure out what the hell that is. And then I can put it in. So I don't have too much shit happening in one thing. Right? So I think some of you guys are just getting lost in everything. You're trying to do everything at once, which is a little insane. Right? So this will be, and you're not doing this kind of thing slow enough. So you're making little mistakes on things like this. All right, so that's what I get for that. Right here I am getting the rest of it again. I have no idea what that is. Okay, so now I can put this stuff in. I know what this is now. That is all this business here. Oh my God. Oh shit, I got a stray sign. Hold on. Let me not push the wrong button. There we go. All right, where to leave off? Minus g of x, which of course is the original thing, all over h is what the bottom becomes, right? So then the top, 3x squared minus 3x squared, -2 minus -2, they all cancel, and I end up with 6xh plus 3h squared divided by h, and I can cancel an h out of both of those, 6x plus 3h. Kabam, kaboom. Is that all right? So that's exactly how these weird dudes work, right? I think you have to do number 9, so that's pretty much how number 9 is going to work. Okay. Anything else, guys? Any other questions? And this makes sense? Is this okay? So for some of you guys, it's just a question of breaking the work up a little bit, because you make little mistakes when you have too much stuff happening all at once. And there's nobody ever said that it all has to happen at once. Nobody. All right. That to me is the thing. I'm pretty good at math, and I think I had an advantage because I always sort of naturally broke things down. The whole thing of math is if you can break the problem into smaller, easier parts, dude, you got it. So I sort of was able to do that naturally, right? And I'm not bragging because I can't do shit with cars. So I didn't have skills in all these other areas, but that was a good skill I had that made math easy for me, or easier. Okay, let me clear all this away. You guys ready? All right. No other questions, guys? There is something that's driving me a little bit crazy with when you have to find intervals like these problems here. Let me see what's a good problem. So like this problem. Let's see. Yeah, I think this, yeah, you had to do this problem, didn't you? Darn it. I don't want to do a problem you had to do. Here, this, no, I want a nice problem. No, you bunch of dorks. Yeah, this is fine. Can somebody, all right. I think you guys are mixing up intervals and points. So so where is this increasing? Well, one way to answer that question, as you ask, can Jeff spell? Well, sometimes. One way to answer the question is to say, where are the turning points, right? If I can find a turning point, then that must mean on one side of it, it was increasing, and on the other side, it's decreasing. So how many turning points are there in this graph?
2.
2. There's one right there, and there's one right there, which means the interval from negative infinity up to the x corresponding to that point, that is where it was increasing. But you guys are looking at these values and shit. No, the intervals where it is increasing is the x values. Where is this function doing something, increasing from negative infinity up to about negative 2.5, it looks like. Is that cool? Become a thing. And where else is it increasing? Where does it start? Where's the other turning point, of course, is at here. So it's increasing from 1 to infinity. It keeps going, it keeps increasing to infinity. So you really have to divorce what's happening up and down from your answer to the question, where is it increasing, where is it decreasing? You can't say it's increasing at a point. It's not good enough. You got to say it's increasing and decreasing on an interval. So it must be decreasing from negative 2.5 to 1. That's where it's decreasing. Over this interval, it's decreasing, which fits in right here. See that? That's the part that was missing. Okay, maybe. Are you guys all right out there? All right. I keep asking that because I can only see about 1/5 of you. So I don't know what's happening behind some of those. All right. I'm going to clear this away. All right. So that's enough of me asking questions for you. Anything else from homework? Okay. We're going to get into the next level of stuff. So I'm going to start off kind of nice. The next immediate thing we're getting into, so the next chapter we're getting into, let me say this. So the next chapter we're getting into is, it sounds okay, polynomials, remember polynomials? But this is where we're going to get into some of our more detailed by hand graphing. So we're going to learn a lot of techniques to develop a better graph by hand, which you can then check on a calculator or something, right? It's fine to check your work. Anyway, so we'll have to be careful. You don't want to copy stuff from the calculator. Never a good idea. But you can check it. There's nothing wrong with that. Where we start in this section is with quadratic functions. So let's kind of remember what we already know about quadratic functions. Can somebody give me an example of a quadratic while I turn off my black hole? There you go. Anybody? What's a quadratic function? What does that mean? Give me an example.
X squared.
Stop. It's lovely. That I was waiting. Somebody should have just taken that one. I was like, come on, guys. Yeah, so quadratic functions are parabolic, right? I think my pens, hold on. I need a new marker. See if this one works. It's all right. Quadratic functions. All right. So they are parabolic. The most general form for these to take. Does somebody know the most general form for these to take? Quadratic functions. Think about quadratic formula, right? Where do you get the elements for the quadratic formula? The A, the B, the C.
Ax squared plus bx plus c.
There you go. I like it. All right, so that's that. That is all quadratic functions. What can you tell me if A is greater than 0? What does that mean? Does anyone know?
The graph,
So something like, say again?
the graph goes up.
Yeah, then it would look like this. So if A is less than 0, looks like that. Right. All right, that's ground shaking, I know, but do you guys remember that? And that's basically, so if I have x squared, of course it looks like this. Negative x squared is a reflection around the x-axis, so of course it would look like that. We call this cup up and this one cup down. You can also call this happy and sad or some stupid shit, whatever you want to tell. All right, I like it. Now, what is the most important point in a way? You can argue about this, but what is basically the most important point of the parabola? I like that. So what about this one? How does that answer relate to this one, Amanda? What do you really mean? What's it called?
Is it the vertex?
Vertex. Does that sound familiar?
Yeah.
I love you guys. I love you guys. So why is that an important point? Well, let's say you're in a meeting with your boss and you show him this, and this is the profit function. Let's say this is the profit function. Where do you want your company to be?
At the very top.
Shit, yes. So if you have a model of the profit you're going to make, you want to figure out what will get us to the top of that freaking hill, right? Now, most real profit functions are more complicated than quadratic, but locally you could consider them quadratic sometimes. So what we're going to talk about is still applicable because there are situations that are modeled by quadratic functions. For example, I throw a ball and I want to know when is it going to hit its highest point. Well, if I could find the vertex of the parabola that governs its motion, then I would know when it would hit that highest point, right? I like it. I like it. Now, so I've laid some groundwork for motivation for why we're going to do a few things with this bad boy. Can somebody remind me? Let me go back here. Remind me what the quadratic formula is and what it does. What is it and what does it do?
Negative b plus or minus the square root of b squared minus 4ac over 2a.
Yes, I love it. And what the shit does that mean?
X.
Huh?
That's x.
Okay, that's x. That still doesn't answer that question though. That's x when? I love you guys. Anybody remember?
X-intercept.
Yes, those are the x-intercepts. So that's what the quadratic formula does. The quadratic formula solves the equation. All right, let me stop for a minute. That is the only thing the quadratic formula does. In fact, if you solve this, you get here, and I might do that in a minute. All right. By the way, there is a handout that I told you about a while back that's up on Canvas that has to do with solving quadratic stuff. So now is not a bad time to get that bad boy if you haven't yet and take a look at it. Some reminders. So let's take a minute. I am gonna do this. I'm gonna show you how this becomes this. Right? That sounds exciting. All right. But the first thing we have to do before we do that is talk about this. Completing the square. Have we? I can't remember now if we've talked about this. I feel like we have, but
A little bit.
a little bit. Okay, so the basic idea of completing the square is, what would I put here? I'm sorry. Let me start over. What would I put here to make it become something squared? So it kind of makes sense. I want to complete this so it becomes a square, completing the square. And I don't know if you guys remember what that process is.
Be half the
Yeah.
six.
Half of 6.
Yeah,
Squared.
cut the middle term in half, and then
Square.
square what you get. So that is what goes here. You already get the plus, Jeff. There you go. And that, of course, makes it factor like this. When will that work? When this is a 1. That's all you need, is for this to be a 1, and it'll work.
What if A isn't 1?
All right, well, let's build our way up there. Let me make it progressively worse, and then we'll hit to that. That's like the ultimate worse place. All right, I'm gonna erase this. You guys ready? All right. Let's make it 1. All right, let's not make it too much worse yet. So here's the second problem. So what if it was x squared minus 12x? What would you put here? And then how would it factor? Don't say anything out loud. Just take a few seconds. Try to see if you can figure out what you would put. Here are the 2 steps. Okay. So what's the first step here?
Divide -12 by 2.
Take b, right? Ax squared plus bx plus c. Take b divided by 2. And then what do I do with what I get?
Square it.
Square. The end is what you put here, and that makes it factor like this. And if you don't believe me, you can try it. You guys see it? That is how that factors, right? That's a beautiful process. We developed it just by observation. It's just the way the pattern goes. It's nothing really amazing. It isn't. But it is very useful. All right, let's make this 1 level more gross. All right. And I want to show you how even this isn't gross yet. right, so what's the first step?
7 divided by 2.
Yeah. In fact, leave it as 7 divided by 2. So cut the middle in half, and then what do you do with that?
Square it.
Square it. What you get here at the end goes on this side, and what you get in the first step goes here. Done. Was that really more difficult than this? No, it wasn't. Okay, I like it. I like it. And again, if you do multiply this out, you will get this. If you don't believe me, do it. All right. So now let's finally try one that has a number out front that's not 1. Excuse me. All right. 4. Let's do 3x squared. Yeah, well, let's see. I don't want to make this too gross yet. Well, it doesn't really matter, does it, Jeff? No, it doesn't matter. All right, so we do have to do a little bit of work here. This is hardwired to work if there's a 1 here. So I have to have a 1 here. So I'm going to have to take a 3 out. So this will be 3 times something squared. You guys see that? The 3 is out now. So what are my 2 steps? I'm going to erase this down here. I love you guys. What's the first step?
Have 3/10 or divided by 2.
Yeah, so half of 10/3 is 5/3. Is that cool? Let me write this bigger. I don't know why I'm writing so tiny. And 1/2 of 10/3 is 5/3. And then of course I take what I get and square it. So even fractions aren't hard. So this goes here. And then this goes here. All right, now, let's build this up. Let's actually use this practically somewhere, right? What the shit is this good for, Jeff? It's a good question. So let's try this out in a real problem. All right, here we go. I'm going to erase this. So what if I said solve? You can do it, Jeff. Using completing the square. Okay. What do you got, Jeff? Oh, this is gross. I like it. Yeah, I didn't even think about making this not gross. All right, so here's where we're out in the wild now. So what's kind of like in my way? What do I need to have, and where do I need an empty space?
See,
Is this the right
Add
number?
the 2.
Yeah, let me add the 2. Get out of here. I need a blank space right here, right? Now we got to be real careful because before I was just focusing like it wasn't an equation and I was just working with what that becomes. That's all going to happen here now because it's an equation. So what are my 2 steps?
Divide 11 by 2.
11 divided by 2 and then square it, right? Is that cool? So where do I put this? Some of you guys are like, I'll tell you where you can put that, Jeff. No, stop it. Where do I put the 121/4?
The
Both
two
sides.
used to be.
Say again. Yeah, where the 2 used to be. I like it. So I'm going to add 121 over 4. What's the only legal way I can do that in this equation? This is an equation. I've just added 121 over 4. That wasn't there before. What do I also have to do at the same time?
Add it to the
Add.
other side.
The other side.
On the other side. Yeah, of course. We know that. Forever we've known that, right? This is an equation. If I do something to one side, I better do the same thing to the other side. And what is this factor like? I don't have any work to do.
Plug A.
And to do this, I'm going to make this 4 over 4, right? You could 8 over 4. There you go, Clay. So 8 over 4, 121 over 4, 129 over 4. And now what can I do to both sides?
Square root.
Square root. And the minute I do that, what do I have to put?
Plus minus.
Plus or minus.
Plus or minus. Got to represent both possible roots. So then I get, these kill each other. Square root of 129, there is no such thing, but the square root of 4 is 2. You see that? And then I just have to subtract 11 over 2. So because I'm running out of room, I'm just going to do it like that. Oh, can't even see it. My room is crooked. That cool? Does that sound at all familiar to anybody? Hopefully. Okay, now.
Yes.
Well, I'm going to bring this into parabolas. They obviously this relates to quadratic functions. This whole process of completing the square, but there's a whole other relationship. Can somebody tell me? This is something we've already done. Let me see if you guys have paid attention. Where's this guy's vertex? Just x squared. Where's this vertex?
0.
0, 0.
Yeah. 0, 0. So, using your knowledge of transformations, where's this guy's vertex? Why that minus went all crazy.
It's at
1.
1, 0.
1,4.
Yeah, it shifted
Yeah,
1
yeah.
to the right and 4 up. So it went from 0, 0, 1 to the right, 4 up. So now it's at 1, 4. You guys see that? So if a quadratic function is in this form, what form, Jeff? Okay, if a quadratic function is in this freaky ass form, why do we use the letters HK? At the moment I forget. I think there's a historical reason, like it was Herbert and Kevin that was working on this shit. I don't remember, but we just like the letters H and K for vertices and the center of a circle and all kinds of weird stuff. So the vertex of this function would be HK. So if I'm given a quadratic function that is not in this form, can I put it in this form? Yes. So if I'm given a function that looks like this, sure. Well, let's see. Let's not. All right. Let's try to do 2 really quickly in succession. So I'll do an easy one, and then I'll do a hard one. I like it. So can I put this in this form? Yes. So here's what I do. How many sides do I have to work with on this problem? One, because this isn't really a side. Do you guys understand? And you sort of could, but I just don't want you to. I want you to get used to what we're about to do. Forgot how to talk there for a second. Look at what I'm going to do. Look at that. Look what I did. I moved to 3. Get out of the way, 3. I need some room, of course, right? What are my 2 steps now?
Have 8.
Half of 8. And then 4 squared. So that goes here. Now watch. How am I going to do this? I always think about Indiana Jones and the first one, Raiders of the Lost Ark. Have you guys ever seen that movie?
Of course.
If you haven't seen that movie, I don't understand you. That's back when they knew how to make freaking movies. Anyway, there's a scene with the golden idol and the thing, and he doesn't balance his equation correctly, which is why the boulder. So if you don't do your homework correctly, a boulder might fall on you. So just be careful. All right. Balance your freaking golden statues and sand correctly. If you've never watched the movie, too bad. You don't know what I'm talking about. Now, what I'm saying is, if I put a plus 16 here, is everybody cool with me putting a plus 16 there? I have unbalanced this. I better at the same time do what?
Subtract.
I better subtract 16 at the same time, right? If I put a thing of sand on there, I better subtract the golden idol at the same time, or else there's going to be issues. And of course, he didn't balance his equation, right? He didn't have the right amount of sand in his bag. And again, you don't have to watch that movie to understand this math, but I'm sorry. Does everybody see that? Does that make sense?
Can you go over that again for me?
Yeah. Watch.
Just where you got the 16 from. Just that.
Oh, are you not cool with this?
Yeah, I just didn't understand that.
Yeah, so it's the same thing we were doing earlier. Half of 8 is 4. 4 squared is 16. That's what I'm going to add. Same thing we were doing earlier with.
Why is it negative 16 on the other side?
Oh, okay, now that's the new thing. So right now, is that the same as it used to be?
Yeah.
Wait, so this equals this. Is that what you're saying?
Oh no, sorry. No.
No. This is how much too much? This is exactly 16 too much. So how do I make these stay the same by that? Now think about it. Now watch. If you have an 8 and you subtract 4 from it, what can you do to make it become 8 again? Add 4 to it. So whatever I do, if at the same time I undo it, I haven't done shit. And math says, go right ahead. You haven't broken any laws. You didn't change anything. So whatever, weird ass human. Now, so math thinks we're weird when we do this. It's like, whatever, dude. But what is this now? I can rewrite this how? How does it factor now? Right? You guys out there? Yes, this is the same thing we've been doing. That piece factors like this. And what's outside here now?
Minus 13.
Minus 13. So what's the vertex?
For negative 13.
Negative 4.
Negative 4.
Negative 13.
Negative 4, negative 13. Remember, when it's inside here, it's the opposite. Right? Because this makes it go back 4, and that makes it go down 13. I like it.
And how do you graph that? Like as
Believe it or not, I really appreciate you asking that question because I almost forgot to do that. Graphing this is crazy easy. All right, get ready. Get ready. All right, so the first thing I gotta do is pick a scale, right? So I gotta go down to 13, right? I get negative 13, correct? So let me do maybe by threes. Negative 3, negative 6, negative 9, negative 12, negative 15. Okay. So where is, and then I can do 1, 2, 3, 4, 1, 2, 4. That was probably not the best idea, Jeff, but we'll see what happens. So 1, 2, 3, 4. So it'll be -4, -13, right? So about right there. I know my scale is freaky. Is everybody cool with me so far? -1, -2, -3, -4. Can somebody tell me what the y-intercept is? Hint, hint, look up there.
Is it 3?
How, say again?
Is it 3?
No? Yes and no. I'm just being picky. I'm being appropriately picky. Y-intercept is a point.
3, 0, 3.
0, 3. I love it. So when x is 0, you get y is 3. I
Oh.
love it. All right. Sorry, Julie. You're fine, dude. You understand? I am going to be picky because, it's a point. So I can put that point there. Now, what I've done that was kind of dumb. Let me see if I can squeeze this in here. I really want you guys to get this because this is kind of cool. Parabolas are symmetric with respect to the line through their vertex. Let me say that again. You guys, where's the parabola symmetric? It's this line right there. Is that cool? There's always a mirror running down the middle of a parabola. It goes right through the vertex. So if there's a point right here, there's got to be a point right over here. There's got to be the reflection of that point, right? So if you draw a mirror going down through the vertex, you got the y-intercept. You know the y-intercept from the beginning. So you automatically know the reflection point.
-8, 3.
Yes, good. I like it. That's the cool thing about the symmetry of parabolas. That's an easy point to get. You knew it from the beginning. That you get because you have to get it. And then this one is just the reflection. Bam. Done. Okay, I like it. If I would have planned it out a little bit better, I could have made that look better, but oh well. All right, now, what time is it? Okay. I'm going to erase all this. You guys ready? Is the h -4? I'm sorry. Yeah, oh, yeah, the h is -4 because it's x minus -4. So it's just always the opposite of this and exactly this. So -4, -13, because that's what the shifts would do, right? That's what the transformations would do. Okay, here it goes. Let's just jump into this. All right, let's see. Let's do it. Let's do it. What am I talking about? Let's do this one. Get out of there. Let's solve. Wait a minute. Yeah. This is fine. Let's solve this. Okay. This is where I get people, if you haven't tuned out already, this is where people kind of tune out. But I really want you to understand, even in this worst case scenario, this is just a brute force problem. Very little thinking involved. What do I need to get rid of so I can use completing the square? What's not supposed to be there?
The A.
The A. So let me divide by A. And I can also pull this thing over. Is that cool? Yeah, I just killed the A. So x squared plus b over ax equals -c over a. Is that cool? Just pull that out the way I need the space, don't I? All right, I'm going to need a little row of room, so I'm going to do the 2 steps over here. What's the 2 steps?
Have it.
Half of the middle dude. That's how you do half of something. Just multiply it by 1/2. So if it's a fraction you're working with, do 1/2 times it. That makes it easier. And then of course I just square this. Isn't this already looking familiar? No?
Yeah.
A little bit? Okay. So now I add this here, which means I have to add it here. This side is, let me, are you guys kind of with me? This isn't crazy. This is something you can follow. This isn't that big different. This isn't different at all from what we're doing. Now I know this is going to factor how, like this, right? And what do I get over here? Well, I need a LCD, don't I? So what do I have to multiply by to make the bottoms the same?
4a.
Yes, I have to multiply by 4a. Now it definitely should be starting to look familiar. So I get b squared minus 4ac all over 4a squared. And now what do I do to both sides?
Square them.
Square
Root.
root plus or minus all right, I'll do that next. And now I can subtract b over 2a. And the bottom is square rootable. And then I could, they have like denominators, couldn't, so I could put them together and I get my quadratic formula, right? Not that hard, really. What's more important here, let me see, I should have done this before I did this. All right, has everybody got what they want from that? You don't even necessarily have to copy that down. But I at least want you once in your life to see where the hell this comes from in case you never saw that before. So you understand it didn't just come out of our ass. We just go, that sounds good. Let's make kids do this. No, it came from actual ideas. Let me show you guys. I want to make a connection here with you. So we get a shortcut. I want a shortcut. I think you guys can agree with me. I want a shortcut to find a vertex. I want a shorter way to find a damn vertex. Do you want that? Even if you don't, I'm going to give it to you anyway. So, nah. All right, I want to make a connection here. So watch this. If a parabola was like this and went through 1 and 7, could somebody tell me something about the vertex? Anything?
It's in the middle.
True. Be more specific now.
Is greater than 1.
Yes. Be just a tiny bit more specific.
5.
No. What's right in between 1 and 7?
Half the total distance.
I love you guys. Yeah. Right? 4.
Is it 4?
Yeah. Sorry. Yeah, this was my next little tiny hint, was to make this symbol. And all you had to do is figure out, what is that symbol? All right. Now, that's not a vertex, is it? That is the what? That is the x piece of the vertex. How would I find the vertex? I would have to know what the function was, right? And then I could plug 4 in and get what the y value is and get the vertex. Everybody with me? When does that work, Jeff? Always. If I had a parabola and this was -3 and this was 5, could you figure out what the vertex is?
Is it
Huh?
1.
It's 1. Yeah, all you have to do is average these, right? So you get 1. So if you want to know what the y is. Anyway, so what am I trying to say? Remember what the quadratic formula finds? Remember where we started. One of the first things I said, what does the quadratic formula do?
Finds the x.
Finds the x.
Intercept.
Intercepts. I love it. If I know the x-intercepts, the vertex, the x piece of the vertex is right in the middle. of the intercepts. So I really want you to get this. Look at what this says. Doesn't this say negative b over 2a plus something and minus something to get the intercepts? So what is in the middle of the x-intercepts? Freaking negative b over 2a. Freaking negative b over 2a, right? What is that, Jeff? All right, here, this is what this is. Can somebody tell me, I should have written this down and kept track of it. What was one of the problems we did earlier to find the vertex? Wasn't there one like, I can't remember, 11x minus 3? Was that one of them? Do you guys have that in your notes, anybody?
-2.
Say again, sorry?
X squared plus 11x minus 2.
Minus 2, okay. And do you remember what we got for the vertex? Shit, I can't remember.
No.
All right, that's all right. So I should have kept track of that. So real quick, if I had x squared plus 4x plus 1. So go with me for a minute. I'm going to do this a little fast, so I would cut this in half and square it. So that would be add 4, so I'd have to subtract 4. This would be x plus 2 squared minus 3, so the vertex would be -2, -3. This shortcut, all I need to know is what a and b are. So if I'm given x squared plus 4x plus 1, what is b? What's b?
-4, or yeah, 4.
Yeah, b is 4, so it's -4 over twice a is 1. Cool. So the x piece is -2. And then how do I get the y piece? I plug it in. -2 squared is 4, minus 8 is -4, plus 1 is -3, which is exactly what we got over there the long way. So negative b over 2a is a shortcut way to find the x piece of the vertex. How do I find the y piece? The same way you always do. Try to take over the, no, plug it back in. So if I had, all right, here we go.
Wait,
Here's
so those are,
sorry?
I was just gonna say, are those just two different ways to find the vertex?
Yes. One way is to put it in this form, right? And another way is given this, do this, and do this. Right, to get the x piece, and then you plug it in to get the y piece. So this is a shortcut to this procedure. I like it. So if I told you that the profit function for some company was -0.01 x squared, you can do it, Jeff, plus 800x minus 3,000. Sure. All right, let's see what happens. Where x is the number of widgets, I know, sold. How many widgets should I try to make and sell to make the most profit? How do I know there's going to be a maximum for this function? What kind of parabola would it be?
It's a negative parabola. It's upside down.
Meaning it opens down, right? So it's got a maximum. Cool. And of course, the maximum occurs at the vertex. So do you want to do it this way, where I factor this out and I cut the thing in half? Oh, shit, no. I'd much rather do it, holy shit, that way, right? So what's B? What's B?
800.
800. What's A?
0.01.
Oh, 0.1.
Negative 0.01. Right? So if you do that, what do you get?
-4.
No. One
400.
thing is the negatives cancel. The other thing is that's very tiny. So when you divide by it, you get much bigger.
4,000.
Say again? I believe you should get 40,000. No?
Oh, yeah.
If you don't believe me, do it in your calculator. But basically, you move this over once, twice. You move this over once, twice. 80,000 divided by 2, 40,000. What does that mean?
How do you plug that into the calculator? Because for some reason I get 4.
Oh, are you doing, all right, are you doing this? If you plug in there 800 divided by 2 times 0.01, you are not going to get the right answer. Because I'm not multiplying by 0.01, am I?
No.
So you either have to do this, or you have to do 800 divided by 2, and it's divided by 0.01. Do you see that? It's got to be divided by 2 and 0.01. Okay, okay. I like it.
Yeah,
I like it.
I was doing it wrong.
Gotcha. That's why by hand is often better than the calculator. But that's right. That's for another time. What does that mean?
X
What is
value
X?
for vertex.
So say
X value for the vertex.
great, but that doesn't help out my boss who wants to know stuff. What do I tell my boss?
You just plug it in, don't you?
No. What does that mean?
$40,000.
No.
Widgets. So
Widget.
What does X mean? The number of widgets. So 40,000 is the number of widgets to sell if we want to do what?
the maximum profit.
Maximum what?
Profit.
Profit. There it is. If you want to make the maximum profit, you better sell 40,000 widgets. Do you guys see how that comes together? No. Yes?
Yes.
Maybe? Okay. And what is the profit? How would you figure out what the profit is?
Plug it in.
Plug it in. And I don't want to do that. You guys can do that if you want to. Whatever the hell you get when you put 40,000 in there, you could do it. You can do it. Now I'm going to try to do it. Don't do it, Jeff. No, I'm not going to do it. Screw that. No, Jeff, stop. All right. I keep wanting to try to do it. I'm not going to do it. All right. Yeah, that's kind of sucks. I want to show you. So that is going to be one kind of word problem you could get where they actually give you the equation already. So that's an easy, that's not even a word problem. They've already made the equation for you. A real word problem is where you have to make the equation yourself. And those are in this chapter also, right? So in case you were worried, there were no pre-calculus word problems. There totally are. And I think, let me see. This is fine because I really doubt many of you are going to be able to get to chapter 5 too soon anyway. I do have a worksheet that I'm not going to make accessible yet that goes over some word problem stuff. Let me see. Where I want to go. Oh, here we go. I kind of, yeah, why not? Let's do it. Let me tell you this. Let me see what you guys think about this. Real quick. If we go until the end of class today, I will give us tomorrow off. What do you think? Do you guys want?
Yes.
You guys
Yes.
want?
That sounds
tomorrow?
good.
You guys want tomorrow off? Okay, okay, good.
Yes.
Yep.
Then maybe you guys can stay with me now. Okay. So I do want to focus on how to set up equations that you're going to see. So let's take a look at some right out of the book, right out of the homework. Let's see, where am I at? Here we go. Let's figure out how to set these weird ass things up. Let me get to 5-1. Okay. Jihad. All right, so you can see all the stuff they were talking about, same stuff we were talking about. Yeehaw. Okay, so for example, let me see if they have a decent example. No, see, here's one where they give you the function. So it's the rock thrown and it follows this pattern. It's just like the profit one we just did, right? You know what B is, you know what A is, you can find the vertex. That's where the maximum height's gonna be. Maximum because it's opening down. Do you guys see what to look for? Okay, maybe. Okay. Okay. Now look at the very end of this section. This is where things get more interesting. Here we go. Now we're talking about some shit right here. Now watch this. Find the dimensions of the rectangular corral split into 2 pens of the same size, producing the greatest possible enclosed area given 300 feet of fencing. What? All right, there's a lot going on there, right? All right, so let's look at this. All right, this is really neat. I love this kind of problem. Of course I would. So there's a lot going on there. Do you agree? It's a very short problem, but there's a ton of shit happening. All right, first thing is it's split into 2 pens of the same size, right? So it's a rectangular corral. So they got a rectangular. You definitely want to draw pictures with these things for damn sure. Split down the middle. All right. Now, let me ask you this. All right, these kind of problems are so cool. There's something that they tell me, and there's something that they ask me. All right, can somebody see in number 67, what do they just tell me that I don't have to do it? They just tell me, straight up tell me.
So the area is 300 feet of
Careful,
fence-
no, careful. I know those words are close together, but I want to find the greatest possible area. Do you see how that's what they ask me? Producing the greatest possible area given, so here's what they tell me, 300 feet of fencing. Now, if I have 300 feet of fencing, where is that on my picture? Isn't that the lines? Isn't that the fence I'm going to put up? You guys with me?
Yes.
Okay, so that's basically related to the perimeter. Although in this case, the perimeter is a little weird because I have to put fencing down the middle, right? Okay, now, let me stop for a minute. I love you guys. So they tell me that I have 300 feet of fencing. I have to come up with the variables myself. What variables do I have in this problem? Looking at the picture, what do I need to label here?
Width,
Say again.
height, and the width.
Yeah, the length and the width. I love it. So what do you want to call the length?
X,
That's crazy. What do you want to call the width?
Y,
Holy shit. Okay. Now let's be more complete. Let's be nice to ourselves. Isn't this Y also? It's rectangular, so they're parallel, so they are the same length. Are you with me? So become a Y. Damn you. And then what's the other side, of course?
X.
X. I like it. So what is the equation for what they tell me then? I put down all the fencing.
Y equal 300x.
No. How much fencing did I put down? How much is right here? Isn't this X amount of fencing? Isn't this another X amount of fencing? What is that so far?
It's 2x.
2X. All right. Now, how much more did I put down? Plus
3y.
3Y. Do you guys see that? That is basically the perimeter, but adding another line for the middle. Do you guys remember the perimeter is 2x plus 2y, right? So most of you guys know it's 2L plus 2W. So why is one of them 3? Because I got the extra one down the middle.
I have a question.
Yes.
The y down the middle, it's supposed to cut x in half, right?
Yes.
Does that mean that those sorry, the like halves of x are equal to y?
No. You can't
Okay.
make that assumption. I don't know what kind of rectangle this is going to be. So I don't know if these are going to be squares. So it could be this kind of rectangle gives me the best area, or it could be, this kind of rectangle gives me the best area. I don't know. So I can't make any assumptions like that. Now, what is it they ask me? They ask me for the area. Can somebody give me the area of this figure? Don't overthink it.
XY.
Yes. Length times width, right? Now, I love it. I had somebody tell me you have to subtract off the fence down the middle, and I told them you can if you want to. So I want you to realize something. A lot of the math we're doing now is idealized. The closer you get to real life with your mathematics, the more variables you have to bring in, like the width of the fence cutting off some of your area. We're going to ignore that. All right, I don't even want to bring it up. Okay, now stay with me. We got that prize of being off tomorrow, so we're almost there. What is it that I want to maximize? What do I find? What do I want to find the biggest thing? What is it? What do I want to find a way to make the biggest what?
Is it vertex?
Stop. Vertex helps me find how to create that biggest thing, but I don't. Yeah. Read through the problem. Find the dimensions of the corral, split into producing the greatest possible enclosed area. So I want to maximize this. The problem with this equation is the number of variables is too damn high. Just to give a now out-of-date meme, but I have X's and Y's in there. Stay with me. This is so cool. All right. Every problem like this, that is an optimization problem. You're trying to find the biggest or smallest. They will have something they tell you, write the equation for it. They will have something they ask you, write the equation for it. Now, I know this is true. Can I solve this for one of the two letters? And then I could plug it into this equation. So what letter do you want to solve this for? It really doesn't matter.
4x.
All right, let's solve it for x. So I would subtract the y and then divide by 2. Is that cool? That's what x is. I love you guys. So this kind of problem, I write down what they tell me, the formula. I write down what they ask me, the formula. I use what they tell me in what they ask me. How do I do that? I solve for a letter. So now I can rewrite the area. Area equals x. Well, what's x? 300 minus 3y over 2 times y. I love you guys. All right. We're almost there. I wish they would have taught me this way, and I'm sure you're sitting there like, I don't understand a word you've said, Jeff, about this problem. I'm like, damn it. Hopefully you guys are with me a little bit. But there will, anyway, all right, I'm going to keep going. So let me, if I multiply this y through, am I not going to get a quadratic? Do you guys see that? If I multiply the y through? So I'm going to get, let me kind of clean this up a little bit. I'm going to get negative 3y squared over 2 plus 300 divided by 2 is 150 y. Let me stop for a minute. Is that cool? If I multiply that y through and I clean it up a little bit. Now, how do I find the vertex? What will it be now? It's going to be y, because that's the variable I've got going on in here, right? Y equals negative b over 2a. What's b? You could do it. What's b?
50.
150. And what's a?
Minus 3 over 2.
Exactly. They don't change, right? B is in front of the y. A is in front of the squared piece, right? What's really nice down here, bam, bam, the negatives cancel. 150 divided by 3 is 50. Look at that. That came out way nicer than you thought it would. So that's 50, what was it, feet? Yes, 50 feet. So this is 50 feet. That's 50, so that's 50, so that's 50. How do you figure out what x is?
Plug it in the equation.
Yeah. If you plug 50 in here, you get 150. Subtract it, you get 150 divided by 2 is 75. So that's 75 feet. If you didn't follow what I just said, you just plug y in here and solve for x like you always would for a system of equations, right? All right, that was a lot. I understand. But the nice thing is we have tomorrow off. So I'm going to post the answers for that. What do you call it? You can do it, Jeff. The practice.
Worksheet.
Yes, thank you. Oh, man, it's been a long day. And on Monday, we can go over it. I'll post the solutions over the weekend. So on Monday, we can go over any questions you have. So you should be prepared for the quiz that's happening on Monday, the 22nd. I like it. All right, guys, good job. You made it. You survived. That's plenty. So you guys are free to go. Enjoy your weekend. Let me know if you need to hang out, if anybody's got a question. Yes?
Wait, we don't got class tomorrow?
Yeah, no class tomorrow. I'm
Let's
gonna
go.
give us, sorry?
Let's go.
Cool. Yeah, that's the way it is, man. I told you I was going to give you a few days off for Zoom fatigue. I know we just had a holiday, but who cares?
All right, thank you, Professor.
All right. I'll see you guys. Bye. Everybody good?
Quick question.
Yes.
Where do we submit the quiz corrections?
Same place you submitted the quiz in the first place.
Okay, got it.
So it's going to say it's late, but you know it isn't. And so do I.
Got it. All right, thank you.
Welcome. Everybody else good? All right, I'm going to head out.
Yeah.
I'll see
Have
you guys.
a good night.
Thanks, Austin.